Hi, welcome back to Circuits with Angel. Today, we will be building an RGB LED circuit and talking a bit on how you can save some battery on our electronic devices such as phones, tablets, or laptops. First, we have to learn about what is an RGB LED. A RGB LED is an LED with red, green, and blue LEDs inside of it. They are small, but they are separate. Each one of the legs of the RGB LED powers one of the colors. Because the LEDs are so close, when more than one of the LEDs are powered, it makes it a completely new color. On some of our LEDs, we have a layer that makes the colors blurred or smooth. It is called a diffuser or even a frosted layer. This layer is nice and beautiful, but other RGB LEDs are clear. They aren't as pretty, but we can see each color more clearly, and roughly where each small LED is. The top of the clear RGB LED has a magnifying glass effect, which makes them very bright from above. Be careful looking at the RGB LED from above. I thought I'd talk about that because I have different RGB LEDs for different experiments later. So that's a quick summary of our RGB LED. Now that we know more about our component, we can build our circuit. Here are the components. We will need one breadboard, one 6-volt battery pack, 3 470 ohm resistors, 2 solid core jumper wires, 3 push buttons, 3 stranded core male-to-male jumper wires, and finally an RGB LED with a frosted layer. Oh, and don't forget to make sure your battery leads aren't touching. I was just making sure. Okay, so now that you know about that, we can go plug in our power supply to our breadboard. Red goes to red on this rail, but on the other side we're going to do something a bit differently. We're going to put a jumper wire there later to measure current. You'll see in a minute or so. Now let's get building. We will have 3 push buttons, all 2 spaces away from each other, so they have some space. I like how it looks when it's 2 spaces apart. It looks less cramped than if you were to put them closer together. This may take a bit of time though, because the push buttons can be kind of bouncy and I have to put them really in there. Alrighty then, we just gotta make sure our push buttons are the right way around, and then we take our 470 ohm resistors and connect them to our push buttons and the negative rail. We're gonna put on the bottom rightmost leg on each of the push buttons. It really doesn't matter which way you put it, left or right. Just remember that when you put in the jumper wires that connect to the RGB LED, that the jumper wires go across from the resistor. Sometimes the resistors are a bit difficult to keep in there. Yeah, that's what our circuit is supposed to look like right now. Our RGB LED's legs need to be a bit spread out so they fit in the board. Now remember, the long leg of the LED goes to positive, and it still goes for an RGB LED. So ensure just make sure that you plug positive voltage to the long leg of the RGB LED or else this won't work. So our long leg gets a jumper wire from it to positive. I kinda knocked the RGB LED, and now it's going to be a bit difficult to shove back into the board. After that, the opposite leg of our push buttons to the other legs. By opposite, I mean across the push button to the other leg. You can use solid core jumper wires that are a bit longer instead of these male-to-male stranded core jumper wires, but I find it a bit easier to use the male-to-male stranded core jumper wires. Oh, and if you don't put the stranded core jumper wire the opposite leg of the resistor, then your RGB LED light is constantly on, which would mean if you connected them all properly, the RGB LED would show white all the time. Alright, make sure that all those stranded core jumper wires are connected to the shorter legs of the RGB LED, and we could move on. Just gonna look from up top, and that's how it's supposed to look. We are going to be measuring the current in this circuit, so we get to make a place to break into. I figured the best place to do this is a place where there are no branches in the circuit, so it's less confusing. So all you had to do was just make a jump wire connecting those two, and ta-da! Man, the colors are so much brighter in the camera than in real life. It looks very smooth in real life, but it's really bright right now. Ooh, I like this light blue color a lot. Oh, and this is a really nice light purple if you could see it in real life, but no, this one also has a magnifying glass effect, which makes it super bright on camera and above. And pressing all the buttons makes white. How exciting! Alright, enough playing around with the colors. We are going to measure current. We're going to need 2 multimeter leads, 2 alligator clips, and 2 stranded cord male-to-male jumper wires. And why, of course, we would need the multimeter itself. First, we take a jump wire connecting the negative voltage to the negative rail. And we're just going to go ahead and replace that with 2 stranded cord male-to-male jumper wires. I'm just going to call them male-to-male jumper wires from now on. Make sure they're both in each row, or else the measuring won't work, and then you will see nothing on your multimeter. And after that, we just take our alligator clips and clamp the jumper wires to that. It doesn't really matter what color you have jump wires ever, but I just make them different colors so you can tell the difference. After that, we clamp the alligator clips to the multimeter leads, and then we plug our ports in to 200 milliamps and common port. Make sure you press down to make sure the things are connected to the multimeter. After that, we're going to turn our dial to 200 milliamps, and we're going to get measuring. Alright, now that we can measure current, we're going to get measuring it in a second year. Alright, let's get measuring. The current is the same in all parts of the circuit in a series circuit, so we don't have to go bounce around measuring places. And blue was 6.5 milliamps. Because it's negative, we gotta switch around our leads so it shows up not negative. Green is 6.7 milliamps, and it is not negative. Red normally doesn't take very much current, but in this circuit it takes 8 milliamps. And this is supposed to be yellow, so this is 14.5 milliamps. Oh, and this is the nice light blue I like. This one is 13 milliamps. This light purple, or lilac purple, is 14.4 milliamps. Boy, oh boy, white sure does take a lot of milliamps. 20.7 to be exact. Alright, now that we've done that, we can talk about what the point of this video was. Okay, the first thing it was supposed to do was show you how you could possibly manage your energy in your devices better. Because proper energy management in electronics is very important. Because that in every device with a screen, the screen is made up of hundreds of thousands, sometimes even millions of RGB LEDs, and each is powered individually. No matter how big or how small, all RGB LEDs work on the same principles. The brighter the color, the more power it will take, and the darker the color, the less power it will take. And we're going to define power really quick before we continue. Power is a measure of the overall amount of work being done in a power supply. In a circuit, we can find the power using the formula P equals V times I, or power equals voltage times amperage. The more power, or watts, the more work the power supply has to do. And that drains the batteries in the power supply faster. Alright, now a lot of devices use a lot of light, and they're very bright. So the idea is that if you lower your brightness and change the theme of your device to dark, if you already haven't, you could save some power. Now, that's all for today. Thank you for watching, and see you next time.